Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today we're going to be in Chapter 12, Lesson 2, Introduction to Functions. Last class we talked a little bit about functions. What are they? And one of the things that I gave you is right here on the screen, and it says functions are equations which relate to variables in which each or every possible input yields one and only one output. That's an important thing for you to understand. These are equations. They have two variables, okay? It's an x and a y. We talked about that with direct variation. So two variables, x and a y, in which every possible input, so every time you put something in for x, remember x is the input. Every time you put something in for x, it only gives you one answer for y. What if you get two answers for y? Not a function. What if you get 0 answers for y? Not a function. What if you get 20 answers for y? Not a function. The only possible solution to a function is one and only one output. It's very important to understand. We're on page 457 in your book. Is the page number 457? There's some steps here to determine if an equation is indeed a function. How are we going to do that? Well, the first thing that we want to do is we want to solve for y. Solve for y. Okay? What does that mean? Well, whatever they give you, just solve it for y. In other words, get y by itself. Get y equals something. Second, we want to determine if the solution has one and only one solution. Number 3, if it has more than one solution or no solutions, it is not a function. If it only has one, then it is a function. So here's what we're doing in this little section right here on page 457. All we're doing is saying yes or no, this is a function. We're just determining if it's a function. So let's go ahead and look at some of these. 3x squared plus 2y equals 4. Is that a function? Well, I don't know. Maybe it is, maybe it isn't. So we need to determine if it is or if it isn't. Some of you might be looking at this right here and you might say, I don't think that's a function because I think that's going to give us two answers. Okay, maybe. But remember, we're solving for y. We're getting y by itself. We're not getting x by itself. So let's see what happens with that. Okay, so let's go here and we want to solve for y. That's step number 1. How do we solve for y? Well, we want to take everything over. We want to get y by itself. So we want to take this 3x squared over here to the other side. How do we accomplish that? By subtracting 3x squared to both sides. Sorry. There we go. And now we're going to end up with 2y equals 4 minus 3x squared. Now what we need to do is we need to get y by itself by dividing both sides by 2. Okay? All right, so now we end up with y equals 4 minus 3x squared over 2. Now, here's the question at this point. Okay, is it or is it not a solution? And you'll notice your book has it solved just a little bit differently. I personally like it like this better than the way that the book did it. The book kind of made it more like in y-intercept form, which is fine, but we did it like this. So either way, if you look at the book, they did it right. If you look at mine, I did it right. It's just two different formats of writing it. So now here's the question. How many answers do I get? And this is where you might want to try one, and you might want to say, okay, well, what does that mean? How many answers do I get? So let's put an input. Let's say x equals 1. When we put x equals 1, what happens? We get 4 minus 3 times 1 squared, which is 1. 3 times 1 is 1, so we get 4 minus 3 over 2. 4 minus 3 is 1/2. Y equals 1/2. That's one answer. Okay? So when we solve it, we only get one answer. Now, if I put a new input in, I will get a different answer, but I'm still only getting one answer for every input. What do I mean by that? If I put a different x in, so that was x equals 1, what about x equals 0? We'll put x equals 0 in. So now I have 4 minus 3 times 0, or 4 minus 0, or 4 over 2. 4 over 2 is 2. Now y equals 2. One solution. Every time I put something in for x, I get one solution out. So the question, is this a function? Yes, this is a function. Why? Because I'm only getting one answer every time I put in a different input. All right, let's look at this one. Again, we want to solve for y. We want to get y by itself. So I'm going to subtract 2x from both sides, and I'll get 3y squared equals 4 minus 2x. Divide both sides by 3, and I'm going to end up with y squared equals 4 minus 2x over 3. Now, how do I get y by itself? I have to square root this. What happens when I square root this side? Well, this cancels, but I get a plus minus over here. What happens when I get a plus minus? That's two answers. This is two solutions right here. So immediately when you see that plus minus, you know, okay, I'm getting two solutions. So is this a function? No, this is not a function. Why? Because it has two answers because of the plus minus. All right, here we go. Here's kind of the last one that I want to show you. It is also on page 457. Get y by itself. Well, good luck with that, right? What, Mr. Steve, what do you mean get y by itself? There's two y's, there's a y cubed. I don't even know how to do that. You don't know how to do it because there is no way to do it. You can't get y by itself here. It won't work. It doesn't. These are different terms. Now, you could try to factor out. Watch what happens if I try to factor out. So if I say y or x equals y, so I pull a y out of there, I still have a y squared minus 4. So I kind of got y by itself, but then I didn't get y by itself because it's got more stuff over here. So it's confusing. There's no way to do it. Okay, so I'm going to divide everything by y squared minus 4. Y squared minus 4. Okay, so that cancels. Oh, y's by itself. No, it's not. Look, there's y over there still. Okay, and that's a 4, but so you can't get y by itself. It doesn't work. So is this a function? No, this is not a function. Okay? Because you can't even get y by itself. On the bottom of page 457, you're going to see a word that says function notation. What is function notation? Well, it's the way to write a function. What this does is this signifies to everybody who's looking at it, hey, this is a function, okay? The way that you do that is you change the y, you take the y out, and you input f to the x. Okay, what does that look like? So my formula was y equals, let's say, x plus 2, okay? I'm going to take out this y, and I'm going to put in this function of x thing right here. So we write it with kind of a weird looking f. It's like an italics f, so it doesn't look like a variable. The function of x equals x plus 2. When everybody sees this, now they know it's a function. When they see this, they might not know it's a function. They might just think it's a regular equation and whatever. But when you put that function of x, you're telling everybody looking at it, hey, this is a function. All right, now here's an interesting thing. Look down here, evaluating a function with varying inputs. What does it mean to vary the input? Well, it means to change the input. So let's say we say x equals 5. Well, now where there's a function of x, we would put the function of 5. Why? Because we're switching, we're making x equal 5. And then we'd say that equals 5 plus 2. And then we can solve this, and we could say the function of 5 equals 7, and that would be our answer. The function of 5 equals 7. Now watch what happens when we change the function again. So now it was function of 5. Now we're going to change it. Let's say the function of 7. So the function of 7 equals 7 plus 2. Notice where everywhere there was an x, I put a 7. All right, so now the function of x equals 9. As the input changes, the output changes. That's why it's called the dependent variable. It depends on whatever x is. All right, so let's do a few of these a little bit more complicated. We are now on page 458. Page 458. All right, so evaluating a function with varying inputs, substitute the values for x. That's all we're going to do here. This is our function, okay? Now it says down here, the yellow, we want to do the function of 64 instead of the function of x. So everywhere that you see an x, you're going to put 64. And then you just solve it. So what is 64 minus 40? That is 24 divided by 2, and that would equal 12. So in this case, the function of 64 equals 12. Remember, you always get one output. You always get one and only one answer. So now we're going to do it for the function of 30. So now here, instead of x minus 40, we're going to put 30 minus 40 divided by 2. And then we'll just do that. So that's negative 10 divided by 2. That equals negative 5. So that function of 30 is going to equal negative 5 once we solve it out. The next one is function of x plus 38. So where there is an x, we're going to put x plus 38. So we'll have x plus 38. That's in place of the x minus 40 divided by 2. You might think, oh, that's weird. I don't know how that's going to solve out. The only thing here is it's going to solve out, and we're just still going to have an x. We're not going to have a number. We're not going to have 2 or 6. We're going to have x minus something or x plus something. All right, so what's 38 minus 40? That would be x minus 2 over 2. That's as far as we can go with that one. Okay, you might say, oh, but I want to cancel the 2's. You can't cancel the 2's because of this negative sign right there. That subtraction, that's a binomial, and down here is a monomial. So you cannot cancel binomials and monomials. It's not a thing. So your solution, and it's only one solution, is x minus 2 over 2. You might say, no, that's more than one solution because I have an x, I have a minus 2. No. It's one solution. It's only one answer. Now, if we knew what x was, then we could plug that in, but we don't know what x is. So this one is going to be the function of x plus 38 is going to equal x minus 2 over 2. That would be your answer. Okay. All right, well, there's lots of different things for you there to kind of look at, pay attention to, slide it back if you missed anything. Try some of these practice problems. In algebra, just like in life, when you practice and when you practice doing it the correct way, you're going to get better. They say practice makes perfect. Well, I don't believe that personally because it doesn't. Because if I practice basketball all the time, I'm never going to be perfect at basketball, but I will get a lot better at basketball. So if I practice whatever, if I practice math all the time, I'm going to get better at math. So practice, practice, practice. Okay? All right, we'll see you later. Have a good one. Bye-bye.